Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. You all know that BHEL announced its notification for electrical engineers recruitment. So YourPedia has launched its module upon the request of many students for BHEL written examination preparation. You can join YourPedia module for your written examination preparation in the branch of electrical engineering. It is one of the best module for your preparation. So we are giving some videos from various subjects of electrical engineering, the solution of previously appeared questions in the BHEL examination. Networks was done, already released to you, and this is control systems previously asked BHEL questions in the branch of electrical engineering from the subject control systems. I am going to solve in this session now today. Okay, let's read the first question. The very first question is, in a Bode plot, okay, if the value of the phase at gain crossover frequency is minus 125, then the phase margin is asking what is the phase margin. Yeah, what is phase margin, ma? Phase margin formula is very simple, ma. Phase margin is 180 plus 5GC. Now let's understand what is this 5GC. Let's understand what is that 5GC. 5GC is angle of the transfer function. Which transfer functions are? Open loop transfer function at omega equal to omega GC. Yes, at omega equal to omega GC, where omega GC is what? Gain crossover frequency. What is that? Gain crossover frequency. Gain crossover frequency. Now what he given for us, he is saying that the value of the phase at gain crossover frequency means this 125 is happily 5GC, then phase margin is equal to 180 plus 5GC is nothing but minus 125. So you will get it as 55 degrees. So this question was asked many times in many exams, state level, central level exams, not in the gate. Sometimes one of the time it was asked in gate also, I remember, gate or ESC, I didn't remember exactly, but one of the simplest question, just a formula based only. See, either it is BHEL or BEL, most of the questions are direct formula based, one liner or two liner. Okay, let's go to the next question. The question is saying, if the poles are more than zeros, is saying, brother, there is a transfer function here. Poles are more than zeros means see, denominator is D and numerator is N. I can say denominator order is greater than numerator order, then the number of root locus branches is equal to, see, number of root locus branches is equal to, I repeat, number of root locus branches is equal to number of poles or number of zeros, which is greater. In those two, which one is greater, equal to that is the number of branches of root locus. Number of root locus branches are equal to number of poles or number of zeros, which among those two is greater. Read the option. Number of zeros, no. Sum of the number of poles and zeros, no. Difference, no. It is equal to number of poles. So if number of poles, see, if zeros are more than poles, if zeros are more than poles, then your answer will be this one, number of zeros. Number of branches of root locus is equals to number of zeros, right? Let's go to the next question. What will be the damping ratio zeta in a series RLC circuit excited by DC source? This need not to be DC source, it may be any source. Zeta is damping ratio. It is going to depend on the value of R, L and C, the values of R, L and C, but not on the excitation that is given. The excitation may be DC or AC or whatever it is, right? So here two formulas I am giving, both for series RLC and parallel RLC. Try to remember. Yes, let me write for series RLC. I will tell you how to remember this formula also. Zeta is equal to R by 2 into under root of C by L. R by 2 into under root of C by L. Parallel RLC for parallel RLC. Yes, here how to remember this one, sir? Zeta is having no units. Yes, it is not having any units because it is a ratio of two same unit quantities, therefore it's not going to have any units. So the resistance units are in ohms. Now this L, if I multiply with omega, this will become ohm. As you multiplied with omega in the downside, in the upside also you have to do the same, so that value is not going to change, right? So this omega c will be 1 by x, that will be 1 by ohm. 1 by ohm, 1 by ohm under root will be 1 by ohm. 1 by ohm is gone. Means sometimes if you forget, so these units are 1 by ohm. If you forget whether it is a C by L or L by C, check the units. The final one unit should not exist. Finally, the unit should not exist for zeta. Now, sir, how to get this parallel RLC formula? Zeta of parallel RLC is 1 by 2 will be as it is. In network analysis, there is a concept of duality. Okay, what is the dual of resistance? 1 by resistance is the dual, or conductance is the dual. What is the dual of capacitance, inductance? What is the dual of inductance, capacitance? This way you can remember. For both, there is a frequency called as a natural frequency of oscillations. Either it is series RLC or parallel RLC. The formula of natural frequency of oscillations in terms of radians per second is 1 by root LC. If he is asking Fn, now you will get simply that is 1 by 2 pi under root LC, right? Yes or not? Yes. Now the option is yes. Look the option carefully. Direct option is not available. Okay. Check which of these following options are going to match with this one. See, last one. So already answers are mentioned by him in this one. Check each and every one. So what is the last option? Answer given by him is last option. Let me check that. Okay. 2 into under root of LC. With this root L times gone. Yeah, this is by 2. Yeah. No. We committed a mistake. Yeah, R by L. This R by L by total means it will be yes 1 by 2 into this will go upside root LC. Root L times gone. Simply this is 1 by 2 into R by 2 into under root of C by L. Tallied. Last option is tallied. See, in hurry we commit mistakes. He did not given the direct answer. Some small multiplication division trick. It's not a trick, in fact. Okay, we have to simplify it. That's all. It's not any trick. Sorry, it's not trick. Just a simplification. We have to take it up. Right. Let's go to the next question. A system is given by G of S is equal to K by S into S plus 2 into S plus 4 and H of S is equal to 1. What should be the value of K for the system to have stability? For a third order system, yes, for a third order system, this way, G of S into H of S is equal to K by S into S plus A into S plus B, where A comma B are greater than 0. Then these are the conclusions what we get. So I am not going in detail about the RH criteria. Just for this kind of structure in classes we will derive. In classes I already derived it. Okay, the condition for stability is 0 less than K less than AB into A plus B. System is stable. What is that? System is stable. Let me write all three conclusions. Yeah, K is exactly equal to Kc, or I call it as Km. Kc stands for critical gain, Km stands for marginal gain. The value of K for which your system is marginally stable or critically stable, both are same, is said to be critical gain or marginal gain. The formula is AB into A plus B. So at this point of time, for this value of K, the system is marginally stable. What is that? Marginally stable. If it is marginally stable, it is going to oscillate with some frequency. Omega oscillations is equal to under root AB radians per second, and if K is greater than AB into A plus B, the system is said to be what? Unstable. System is said to be unstable. Now what is asking? The range of gain K for which the system is stable. Yes, this is the value, that is 0 less than K less than AB into A plus B. 4 into 2, 8, 8 into 6 is 48. 0 less than K less than 48. Yes, option is 1. So the general procedure for this one, so you may be having some doubts or how we got these things. We learn in class in I can say general procedure. Routh-Hurwitz's criteria is the procedure, that is one of the simplest procedure. We will take up in detailed analysis once we enter into I can say stability, control system stability, right? Yeah, next question please. So he given one plant and controller, one block diagram he mentioned very clearly. What will be the natural frequency for the above controller? Okay, get its characteristic equation and compare with standard. Get its characteristic equation and compare with the standard characteristic equation. I am solving here. Yes, what is the characteristic equation? Characteristic equation is equal to 1 plus GSHS 1 plus, yes, 1 plus Kp into 1 plus TDS into 1 by Js square. 1 by Js square is equal to 0. Now let's get it. What we get? That is Js square plus Kp plus Kp TDS is equal to 0. Just come here. Js square plus Kp TDS plus Kp is equal to 0. Now let's take this J common. Why? Because you will understand why I am taking J common. Kp into Td by J into S plus Kp by J is equal to 0. Now this is to be compared with standard one. What is the standard one? S square plus 2 zeta omega n S plus omega n square is equal to 0. Omega n square is equal to 0. Now he is asking for the natural frequency of oscillations, or simply natural frequency omega n. Now this omega n is compared with this one. From that what we get is omega n square is equal to Kp by J. So from that omega n is equal to under root of Kp by J. Under root of Kp by J. The option 2 is perfectly suitable for the given question, right? All these are previously asked BHEL examination questions, right? Now what is this question? If the poles of a closed loop are complex with positive real parts, then the system is very simple. This is a complex plane. We also call it as S plane. Yes, this is called as what? S plane. Yes, this is the origin. This is S plane, right? Now if any poles are there in the right half of S plane, those may be in complex manner or in real format or repetitive in nature, distinct in nature, whatever it is. If there are poles in the right half of S plane, system is said to be unstable. System is said to be what? Unstable, right? And if there are poles on imaginary axis, this is imaginary axis, without repetition, okay, system is said to be marginally stable. With repetition, unstable. With repetition, unstable. I repeat the statement, you need not to worry. If poles are there on the imaginary axis without repetition, multiple poles means at one location, if there are no multiple poles, that is marginally stable. At one location, if there are multiple poles, unstable. Now no poles in right half of S plane, this is called as right half of S plane, or RHP in very simple language, and this we call it as left half of S plane, LHP. If poles are there on LHP in any manner, We are least bothered whether they are complex in nature or real repetitive, real distinct. We are least bothered. System is said to be stable. This entire region is, let me go with a different color, as it is a stable region. Yes, this is a stable region. Yes, four things are very important. If poles are there in the right half of S-plane in any manner, we are least bothered in what manner they are existing. System is said to be unstable. Now right half of S-plane is done. Imaginary axis is having 2 points to remember. That is, the first point is, if there are poles on imaginary axis without repetition, system is said to be marginally stable. If poles are there existing on imaginary axis with a repetition, unstable. Now 3 points are done. When you come to left half of S-plane, whatever may be the way the poles are existing on the on the left half of S-plane, the system is said to be what? Stable. Right? Now he is saying, if the poles of a closed loop are a complex with positive real part, if real part is positive, means those poles are existing in the right half of S-plane. Therefore, your system is said to be unstable. Unstable means, yes, unstable means, see, system is said to be unstable. See, unstable means its response increases without bounds. Without bounds, see, I'll say S is equal to, these are the poles, A plus JB, okay, S1. S2 is equal to A minus JB, yeah. This is what he is talking about, where A comma B are positive. A comma B are positive, then only they will exist in the right half of S-plane. Now if you take its impulse response format, this will be some C1 into e power plus AT into sine BT plus C2 into e power AT into cos BT. You will get it as cos BT. If you see, this is sinusoidal, this is exponential, that is exponentially increasing oscillations. Yes, how it looks, sir, I will draw how it will look, sir. So if you are good at mathematics, simple mathematics, you need not do that good also, very simple mathematics. Let me write the format here. So impulse response is equal to C1 into e power AT into sine BT plus C2 into e power AT into cos BT. If you draw, that is a standard. Sir, how we got this one? Yes, for that there is a procedure. Okay, for different poles configurations, we will get different formats of the impulse response, just how you learn in differential equations. Okay, depending on the location of the roots, or depending on the roots, you are going to get a homogeneous solution, right? Homogeneous solution. So every differential equation is going to have homogeneous value solution and particular integral. Homogeneous solution is going to have some format. In that way we have the same from mathematics it is. Now if you try to draw this one, this A is positive, this is exponentially increasing. Exponential increment will be this way in both the directions. Now these are the oscillations. Yes, this way oscillations keep increasing without bounds. Yes, this is exponential and oscillatory. Which option is suitable? Exponential and oscillatory increase, right? Exponential decay, no. Decaying and oscillatory, no. Exponential increase, no. It is exponential and oscillatory increase, right? Let's go to the next question, please. What he is saying? Determine the gain at the break point of the open loop transfer function. GSHS is equal to K by S into S plus 1. This is very simple. Whatever may be the point, if a point is existing on root locus, it must satisfy the magnitude condition. What is the magnitude condition? Magnitude of the open loop transfer function at that particular point, S is equal to S1 must be equal to 1. This is the magnitude condition from root locus. What is this? This is magnitude condition, yes, from root locus diagram. Right? Now what is that? K by S into S plus 1 at S is equal to S1. What is the value given by him? At which point? Break point. Yes, he is asking the break point. How to find break point? At break point, first of all, let me find at break point. at a breakaway point or break-in point, dk by ds must be equal to 0. This is the condition. But sir, how to get the equation for k? So from here, this is equal to 1. So from this one, k is equal to what? S into s plus 1, that is nothing but s square plus s. Now do that here. Yeah, 2s plus 1 is equal to 0. Sir, how you got 2s plus 1? This is the k. What is that? S square plus s. If I derive it for one time with respect to s, our variable, yes, 2s plus 1 is equal to 0. From, if you solve this one, you get s is equal to minus 1 by 2. Take that minus 1 by 2 and substitute in this one. You are going to get the value of k. Or in this one, you substitute because magnitude is required for s. K is equal to s is minus 1 by 2 whole square, and this s is minus 1 by 2. So this is 1 by 4 minus 1 by 2. That will be 0.25. 1 by 4 is 0.25, 1 by 2 is 0.5, 0.25 minus 0.5 will be minus 0.25, but as we are taking the magnitude, yes, it will be plus 0.25. Some people will commit mistake by choosing the option minus 0.25, right? Next question, please. Next question, yes. 6 dB corresponds to a frequency response with magnitude is equal to, yes, see. What is the normal value? What is decibel value? Decibel, 1 decibel is equal to 20 log of that particular value. 20 log, how much if I take? Yes, 1 dB. Okay, V0 by Vi we can take. But he is asking what? 6 dB. 20 log of 2 is nothing but 6 dB. Sir, how you wrote directly? I remember these values. 20 log 2 is 6 dB. 20 log 3 is 9.5 dB. Yes. 20 log of 5 is 14 dB. These three things you must remember. Okay. Now remaining values mostly we can calculate. Suppose if 20 log 6 I am asking, you need to remember. 60 can be written as 20 log of 6 can be written as 3 into 2. Log AB can be written as log A plus log B. Logarithms, you know it very well. So 20 log 2 plus 20 log 3. Log AB is equal to log A plus log B. 20 log 2 is 6. 20 log 3 is 9.5. Therefore, it is 15.5 dB. So this way, so here the question is asked about 6 dB. Therefore, it is option is 3, that is 2. Okay, next question please. What is saying? The Laplace transform of e power minus at into cos omega t into u of t is, first of all you have cos. Cos means s by s square plus omega square. But as exponential is there in time domain, if exponential function is associated with in the entire function, then in frequency domain we get frequency shifting. Now s is there if it is minus, here it will be plus. All these very simple way of finding Laplace and inverse Laplaces I taught you in the class. Okay, that's why this very simply we are able to solve the problems. Okay, s plus a whole square. The answer is s plus a by s plus a whole square plus omega naught square. The option is 1, very simply and perfectly, right? Let's go to the next question please. What is this next question? Yes. Which of the following plot is not used in frequency response analysis? First of all, let's list out all the plots. See, first we learn root locus diagram, then Bode plot, then polar, yes, then Nyquist. So these are the plots we learn, and there are some M&N circles and all which are not there in the syllabus. Okay, so all these three are frequency response analysis techniques. This is only time response analysis technique. Again, root locus, yes, time response analysis technique. Now he is asking which of the following plots is not used in frequency response analysis. So the answer is wrong. Nyquist plot is used in frequency response analysis. Which of the following plots is not used? Magnitude versus phase angle plot, that can be used. Bode plot can be used. Polar can be used. Nyquist also can be used. This is the question. Yes, this answer is wrong. It is also one of the frequency response analysis technique. From Nyquist plot, we are going to find gain margin, phase margin, and stability also. Nyquist plot is the extension of polar plot. Okay, the answer is wrong. Please understand that, please. Okay. Next question. Which of the following methods gives the only absolute stability? Absolute stability means just whether a system, just whether a system is stable or not. Whether a system is stable or not means it is not going to tell you if it is stable, more stable, if it is unstable, more unstable. Unstable means it is going to have some poles in the right half phase plane. All that information cannot be given by absolute stability. Routh-Hurwitz's criteria will give just absolute stability. Okay, that is also called as asymptotic stability. Yes, just absolute stability. Nyquist plot, Bode plot, root locus, these three will give us a relative stability also. Relative stability also. Okay. Next question, please. Yeah. A system is said to be completely controllable if it is possible to transfer the system state from any initial state xt naught to any desired state x of t in a specified finite time by a control vector u of t. Yes, statement 1 is perfectly true. What is controllability? A system is said to be controllable if it is possible for us to change its state from any initial state to the required state using some input that is called as input vector in control systems within finite amount of time. Yes, statement 1 is perfectly correct. Second statement, a system is said to be completely observable if every state xt naught can be completely identified by measurements of the outputs y of t over the time interval. That is also perfectly correct. But here, yeah, something is missing in statement number 2. What is that? Let's read it again. A system is said to be completely observable if every state xt naught can be completely identified by measurements of the output y of t over the time interval 0 to infinity. This also should be correct, no? Yes, both should be correct. Yes, there is something typo I think in this. Okay, a system is said to be completely observable if it is possible. Yes, the general statement for observability is a system is said to be completely observable if it is possible to measure all the outputs of that particular system within some finite amount of time, right? Statement 2 is also correct according to me. Okay, I don't know why this fellow given statement 1 is true and statement 2 is false as the answer. Okay, fine. Let's go to the next question, please. 6 dB correspond to a frequency within the magnitude equal to. This is already done. That is 2. Okay. Next question. For a feedback control system of type 2, okay, system is of type 2. Okay, the steady state error for ramp input is, for a type 2 system, yes, for a type 2 system, if ramp input is given, then steady state error is absolutely 0. Answer is 0. Yes. Next question, please. Which of the following methods gives only absolute stability? That is already done. Next. For a given stability error for step input and speed response criteria, the most appropriate controller would be, yes. See, PI controller will reduce steady state error. PD controller will increase speed response, increase the speed of the response, right? Now, but he is asking both he wants, then obviously we have to go for PID controller. Both can be done by what? PID controller, right? Let's go to the next question. The transfer function for the state variable representation x0 is equal to ax plus bu, y is equal to cx plus du is given by, that is very, very simple. Transfer function is equal to c into si, where s is the Laplace operator complex frequency, I is the identity matrix, A is matrix here, Si is a matrix here, C is a matrix here, Si whole inverse into B, B is also matrix called as input matrix, C is called as output matrix, D is called as transmission matrix. C into Si minus A whole inverse into B plus D. Okay, so option 1 itself is perfectly suitable for this. Next question please. A unity feedback control system has an open loop transfer function GH k by s into s plus 4 into s plus 16. Its root locus plot intersects the j omega axis at, the point at which j omega axis, the root locus intersects the j omega axis is nothing but s is equal to plus or minus j omega oscillations. What is the omega oscillation? Just previously we learned omega oscillations for this kind of structure k by s into s plus a into s plus b, that is equal to what? Root AB radians per second. Root AB radians per second, that is under root of 64, that is equal to 8 radians per second, that is s is equal to plus or minus j8. S is equal to what? Plus or minus j8. Option is 3, right? Next question please. The initial shape of Bode plot gives an indication of initial shape, or it can be slope also. Slope, not the shape exactly. It is not the shape. Okay, these are the exact questions from BHEL paper. In paper there are some mistakes. Okay, I just snipped those questions. Typing is not done by anyone. These are the exact in the BHEL paper. Whatever it is there, photocopy of it is taken, so that it will be authenticated for you. Okay, you feel it as authenticated, right? Slope, it is not the shape, or layman's language, it is shape. See, the initial slope of Bode magnitude plot is determined by the I can say number of poles which are present at the origin. The number of poles which are present at the origin of an open loop transfer function is called as type of the system. So answer is type of the system. System stability, nothing to do with the system stability. Nature of the system, time response, no. Order of the system, no. Okay, type of the system it is, right? The lag compensator is used. Yes, lag is similar to PD controller. It improves stability, lag compensator. PI will decrease the stability. PI will decrease steady state error, but stability is decreased. PD will improve the stability, PD will decrease the time response, but PD is not going to reduce the steady state error. If I combine these two, PD and PI, all the requirements can be achieved. So answer is improve both steady state and transient response. No, PD and lag are related to, I can say, transient response. Okay, yeah, I can say improve steady state only, no. Improve transient only, no. Improve steady state and reduce the speed of the transient response. Yes, it reduces the speed of the response. Okay, that point is very important. Okay, improves transient state only, reduce the speed of the transient response. Okay, next question. In control systems, the type of the system depend on the number of poles which are present at the origin of an open loop transfer function. Poles which are present at the origin of an open loop transfer function, that is very important for us. Next question please. The slope of Bode gain plot of a transfer function Ks by s plus 1 into s plus 10 between omega equal to 1 and 10. See, 1 and 10, you are at, see, these are the corner frequencies. This is omega. In fact, we take it as log omega because this is log axis, this is log omega. This is magnitude in dB. The corner frequencies here are, yes, 1 is a corner frequency where there is a pole, 10 is another corner frequency where there is a pole, right? Now if we observe carefully, yes, initially there is a 0, therefore with the plus 20 it rises till here. After that this is plus 20 dB per decade. A 0 got added, that will introduce minus 20, that will become 0. Till here it continues. Yes, this is 0 dB per decade. Now at 10 it is going to be minus 20, yes, dB, minus 20 decibels per decade. Now this is what? This is 0 dB. Yes, the slope is 0 dB per decade. 0 dB per decade. Option is 2. The rough Bode plot I drawn. Okay, In our classroom we learned very simply how to sketch body plot. Okay, with that we can do it very easily, right? In control system, the response is critically damped if critically damped means zeta is equal to 1. Under damped, this is critically damped. Under damped, zeta is greater than 0 but less than 1. Over damped, yes, zeta is greater than 1. Undamped, no damping, undamped, zeta is exactly equal to 0. Damping factor is damping ratio, not damping factor. Okay, this is damping ratio. Okay, see, there are several mistakes in framing the answers in this particular exam. Okay, framing the options and questions also, right? Yeah, so these are all the questions from the control systems which were asked in the previous BHEL examination from electrical engineering paper. Okay, YourPedia started its module for BHEL electrical engineering preparation for the written examination. You can join your hands with YourPedia to accelerate your preparation towards BHEL electrical engineering written examination. Thank you.